Tensile behavior is commonly seen in everyday life, but how do we obtain accurate tensile data? Choosing the right tensile testing method is key. Let's take a look at several commonly used tensile test methods. We will share from 3 perspectives: standard methods for commonly used materials, methods simulating real-life tensile actions, and applications in adhesive testing. First, let's review some commonly used standards for film tensile testing, including those from ASTM, American Society for Testing and Materials, the Chinese National Standard, GB, and international standards. In the standard method, we will explain in sequence from sample standardization to fixture selection. Standard methods require the specimen to be prepared in a dumbbell shape. A punching machine or similar equipment can be used for standardization. The larger ends are for fixture clamping, and the middle section is the test area. Now let's look at how to set the dimensions of the test section in the software, inputting the sample's length, width, and thickness. To avoid breaking at the clamping section and ensure data integrity, protective measures can be added at the gripping areas to increase friction. Materials like breathable tape, sandpaper, or silicone pads can be used. Ideally, the specimen should break in the middle to ensure accuracy and reliability. After standardizing specimen preparation, set test parameters according to the standard. Due to varying ductility, if the tensile distance is too short, highly ductile materials may not break. If too long, brittle materials may continue stretching after failure. Therefore, use a break detection mode that allows the machine to detect breakage and automatically stop the test, ensuring complete breakage and avoiding invalid data. Once parameters are set, the test will yield a stress-strain curve. Let's take a look at how to convert data and units. Reviewing the full testing process and data analysis, the software uses color coding to distinguish batches and automatically calculates Young's modulus, breaking strength, and elongation at break. It also provides averages, standard deviations, and coefficient of variation. Custom reports can be Many types of fixtures can be used for standardized tests. But do different fixtures make a difference? Let's explore the categories and features of various fixtures. After reviewing standard methods, let's move on to the second part, simulation testing. Opening packaging is a daily action, but packages vary in type and shape, making it hard to use a single evaluation method. That's why simulating real-life actions is so important. We can use hinge-type fixtures to simulate how user-friendly a package is to open in daily life. Similarly, the ease of opening a cosmetic lid greatly affects user experience. How much force is needed to open a pull-tab can? Is it suitable for all users? These are crucial considerations. For boxes and cups, we need to ensure the seal is intact and leak-proof, while also ensuring it's easy and smooth to peel open. Let's explore how to evaluate the balance between seal integrity and peel friendliness for box and cup film covers. After the above discussions, we'll summarize the features and applicable scenarios of 3 simulation test fixtures. In the final part, we'll look at how tensile testing applies to adhesive performance evaluation. When using tape daily, residual adhesive is a common issue, especially with low adhesion tapes like medical patches or sticky notes. These tapes may apply easily but leave residue when removed, potentially damaging surfaces or causing discomfort. There are 4 types of adhesive failure: substrate failure, interfacial failure, cohesive failure, and mixed failure. Substrate failure often occurs with labels. When peeled off, the base material remains stuck. Cohesive failure is common with medical patches, leaving glue on the skin. Let's first review standard methods, 180° and 90° peel to measure how easily tape detaches from a substrate. Additionally, there is the adhesive shear strength test, followed by AFRA's unwind force test, which evaluates the ease of unwinding rolled tape. Finally, we have Finit's initial adhesion test to measure the initial stickiness of tapes. Beyond fixed distance tensile tests, force versus displacement, hold tests observe displacement over time under constant force, used to evaluate holding power. For medical tapes, we can simulate different peel angles to assess how securely a patch adheres and how smoothly it peels off, ensuring it feels good when applied and doesn't hurt when removed. As shown in the image, on the left, strong adhesion pulls the skin, on the right, the patch removes easily. From the curves, we see the cooling patch is easiest and smoothest to remove, but may lack holding power or leave residue. The granular foot patch has high, unstable peel forces due to uneven adhesion, while the non-granular version has moderate stickiness and smooth removal. Adhesive performance varies greatly across materials. Different substrates are used for different test types, for instance, stainless steel for peel tests, glass for tack tests, and synthetic skin for medical patch simulations. In holding power tests, stable mechanical force is essential. A PID control system helps maintain consistent force during testing. If force is stable with PID control, while without it, significant fluctuations occur. Finally, let's review the various devices used in adhesive testing, along with their features and application scenarios. For more information, please visit the Lowton Instruments website or contact us directly.